A project is based on detection and analysis of earthquake signals using Labview. We have taken earthquake because it is a natural calamity and it is a serious disaster, and the effects of earthquake are felt years and years after it occurs. So there are various pre-earthquake signatures. Since it's not a single day process, it happens years and years. So we have many pre-earthquake signatures as ground deformations, variation in the water level in the wells, and abnormal animal behavior. And among all this, we have taken variation in the electromagnetic field as the hint for our project. So variation in the electromagnetic fields. So when an earthquake occurs before years or months, due to the pressure faced in the rocks, ionization varies underneath the earth's surface. So because of these ionizations, the electromagnetic field varies, and when we are able to track the electromagnetic field variation, we could predict the earthquake at the prior stage. So our proposed project, the block diagram goes like this. So we have an earthquake catalog. It is already available ready-made database at the NI Labview software, and among which we take from which we take the peak value, and a magnetometer is placed at the earthquake prone regions, and from which we compute it every instant and take the peak value of it, compare the data and alarm it to the nearest geological center. We also save the plots for future use. So step 1, place the magnetometer at the earthquake prone regions. So it is placed every 20 kilometers apart. And step 2 is the analysis of the magnetic field. The magnetic field is sensed every instant, and any variation occurring at the magnetic field is sensed, and we have chosen the threshold value as 20 times as that of the normal value. The normal value is 25,000 to 65,000 nanotesla. So the step 3 is alarming it to the nearest geological center. If any abnormality is found, we communicate it to the nearest geological center. So for simulation purpose, we have used a Hall effect sensor, or otherwise in a wide scale we can use a magnetometer. For Hall effect sensor, we have taken ICMH182. In that, the first pin is given to +5 voltage, and the second to the ground, and third to the analog input AI port 0. So Hall effect sensor basically works on the following principle. Equivalent voltage is produced depending on the variation in the magnetic field. So the variation in the magnetic field is actually equivalent to the voltage produced. So that is the principle of how we simulate it. So this is the interface between the NI Elvis kit and the Labview software. So the block diagram goes like this. First we collect the data, and through DAC assistant kit we connect it to the block diagram, and we have numerous set of values of which we obtained through the Hall effect sensor, and in that we take the peak value and compare it, and from the CORE database that is already ready-madely available with the Labview, in that the peak value is taken and it is compared, and if it's found to be abnormal, an harmful message is given. So this is our experimental setup. This is the magnet, and here Hall effect sensor is placed and the connections are as given. So initially we will not have any signals from the Hall effect sensor, and these are the signals that are already available through the COBE earthquake database. So this is the simulation part. So the front panel goes like this. This is a signal that is this is a dialog box obtained through a harmless earthquake, and this is for harmful earthquake. So an emergency alarm is given to the nearest geological center. So future enhancement, we are planning to communicate and connect all the magnetometers through GPS satellites, and to locate the earthquake prone regions priorly. So the market value is 1192, and when we place the magnetometer every 10 kilometers apart. These are our references. Thank you.